One thing that we do a lot when we are carrying out data pre-processing or wrangling in R is, joining, joining different data sets. So you could read, data from 2 or 3 more CSVs, or have, 3 different data frames, and joining them is really very important. And that's typically done using the dplyr package in the R programming language. Even when we use Tidyverse, it's actually dplyr which is working under the hood. So these are the main kinds of joins. Let's just talk through what joining is and then look at a practical example. So I have a data frame A with columns x1 and x2, and I have a data frame B with columns x1 and x3. So right off the bat you can see that x1 is common for both A and B. So the first thing with left join is, we typically join using the common column, which is x1. So left underscore join will carry out something known as left joining. I provide the names of the data frames A and B by x1. So x1 will be the joining criteria. And what it's going to do is join matching rows from B to A. So what we are going to end up with is x1, so B to A. So B will get joined onto this data frame, so left. So basically, as you can see, my mouse move, the cursor move, we are going from B, which is on my left hand side, to which is on my right hand side, to the data frame on the left. So A is on the left hand side, if you want to think about it that way, and B is going left basically. So B to A and x3 gets joined, and again right underscore join. So we are going to join from here, from A to B, like so. So basically we are moving right, if you see, and we end up with x1, x3, and x2 from A will go here. So it's literally moving in that particular direction. With inner underscore join, we just join the data and we retain only rows in both sets. So again, x1, x2, x3, they all get joined. x1 is not repeated, and I'll get A1T. But because B is common, again the row is common, so I get B to F. But now as it happens, C, I have an entry of C over here, but over here in x1 I have D. So this won't go across, and this is going to be dropped. So I need a common column x1, and I need the row entries to match for an inner join. Now for a full join, it is going to join all data again by x1, but it's going to retain all rows. So with a full join, it doesn't matter. In x1 over here I have a C, and over here I have a D, and I get both C and D, and the empty rows, they end up with NAs. So now let's just look at an example. This is I've set my working directory, and I've read in the library Tidyverse, and remember it's going to be dplyr working under the hood. I'm going to read in my data set, play underscore data, read underscore TSP. Just interested in these columns. User, song ID, and plays. I can ignore this. Head. User, song ID, number of plays. Now I get song data. Again, read CSV, I get the distinct, the unique song ID, title, and artist name. Song ID, title, artist name, and just the unique entries in here. So now I'm going to use an inner join. I create a variable all underscore data. I'm going to have play data, and I'm just going to carry out a bit of summarizing, and then you can see basically how Tidyverse lets you do a couple of operations in one go. using the chain operator. So play data, group by. So remember we have user and song ID here, so I'm going to use that. And I'm going to summarize by the number of plays, and then I'm going to connect it with song data using an inner join. Plays, but true. And inner join. With song data, and obviously all the common rows will be retained as well. So in this case I didn't specify a column, but I want to retain the common columns and the common rows of both the data sets. And yes, it is going to take a bit of time. So now it's joining by song ID, which happened to be my first column. So I get the user, I get the song ID, I get the plays which have been summarized for each of the songs, the title and the artist name. And this is how inner join worked in this particular case.